everyone, we are here to explain the Maillard reaction.
Hi, I am Amina, the leader of this project.
Hi, I am Janice.
Hi, and my name is Chong Weng Wai.
Hi, my name is Ivy Kwong. Nice to meet you all.
Now let us have a look at the physical changes of the food that undergoes Maillard reaction. Maillard reaction is the reaction that occurs in the cooking process of all foods. For example, the color of steak turns brown and aroma is produced. That is why Maillard reaction is known as the science of browning, flavoring, and aroma.
But how does it happen? I am still confused.
It's okay, we're gonna explain this to you right now. So what exactly happened in there to cause such changes? Maillard reaction. Maillard reaction was named after the French physician and chemist Louis Camille Maillard, who first described this reaction in 1912. Maillard reaction is not to be confused with enzymic browning, as there are no enzymes involved. It produces a brown pigment known as melanodin.
Now let's take a look at what happens inside foods upon cooking. Maillard reactions undergoes three major steps.
Step 1 is the initial glycosylation reaction that still does not produce color change as no melanoidin is formed yet. What happens is, upon application of high heat, the carbonyl group in the reducing sugar, which consists of aldehyde or ketone group, reacts with the amino groups of the amino acid in the food, creating glycosylamine.
The reducing sugars in order of decreasing reactivity are galactose, glucose, lactose, and maltose. The most reactive amino acids are lysine, tryptophan, and arginine.
Nucleophilic attack of carbonyl compounds occurs next, and imine of Schiff base is formed by losing water. Imine undergoes a reaction called amandori rearrangement to isomerize and produce a ketosamine.
Do know that the type of sugar determines the compound formed in the rearrangement step. As we use glucose and aldehyde group as the reducing sugar, it undergoes amandori rearrangement and amandori compounds form, while if it's a sugar of a ketone group, it will undergo Haines rearrangement and the Haines compound will be formed instead.
Now we are entering step 2. This chart provides an overview of the Maillard reaction's intermediate stage. The amine group is removed from both amandori intermediates in a pH-dependent condition to form deoxyozones.
There are three pathways for this to occur. When pH is more than 7, it undergoes dehydration to produce 2 water and reductants. Or, when it's more than 7, it can also form diacetyl, aspirin, pyruvaldehyde, and other short-chain hydrolytic fission products can be formed. When pH is less than 7, it produces Schiff bases of hydroxymethylfuranyl or furar.
Now we enter the third and final stage of Maillard browning, the stage where browning of food is observable and aroma and flavors are developed fully. In this stage, aldehyde amines polymerizations and aldehyde condensations occurs, and this leads to the formations of the final product of Maillard browning, meladonins, brown nitrogenous polymer, and copolymers responsible for the brown color of foods and flavor is developed.
The broad variety of volatile aromatic compounds formed in this process also contributes to the food's developed aroma, with different compounds giving distinctive aroma of foods.
Now, let's look into some of the factors that affect the Maillard reaction. Firstly, temperature. Maillard studied the relationship of temperature and duration of heating by himself. He found out that as temperature increases, the rate of reaction also increases. This contributes to a positive result. This also increases the effective collision, or also known as the successful collision, between the sugar and amino group. The well-known Arrhenius equation is intended to describe the temperature dependence of this reaction. The next factor that affects the Maillard reaction is water activity. One of the reactions occurred in Maillard reaction is condensation. Aldehyde dehydration forms water, which affect the water activity in Maillard reaction. When food has low water activity, the moisture in food may be enough for microbial growth. An increase in moisture content at low water activity will cause the rate of browning to increase, as well as promoting deterioration of food texture. The next factor that affects the Maillard reaction is pH. The Maillard reaction is sensitive to pH. As the pH increases, the extent of color also increases. Depending on the cooking time and temperature, thousands of products can be produced in the Maillard reaction. Many of these products contribute to aroma and flavor. There are also products such as alipyridine, which enhance the taste of food. Alipyridine makes the sweet taste sweeter and the salt taste saltier. Some of the examples of Maillard reaction or Maillard browning is the browning of bread into toast, the flavor of roast meat, and the color of beer, chocolate, and coffee. Here is a summary of what we have explained earlier.